Uh, Here we are having a new session by Mr. No. We'll be talking about Spring live examples. So hopefully we're gonna enjoy in this session. Welcome, No, please.
Hi, hello everyone. In this session, I'm going to be making a presentation on Spring Cell, and we're gonna cover some of the features that are provided by this module of the Spring ecosystem. And we're gonna see that with a real life application. It's a small application in which what we are going to do is we are going to create a command line interface using Spring Cell module, which facilitates and makes coding commands very simple in a simple way. So let me start by giving an introduction to Spring Cell. So basically, Spring Cell is a project of the Spring ecosystem that allows developers to create and implement command line applications in a very easy and uh, simple way. The example today is going to be a command line application that is going to retrieve information from a web service, a REST API, and we are going to implement different commands to perform different actions on the REST API. We're going to have commands to find and retrieve information, and we're also going to have commands to manipulate, update, and delete information. And then we'll explore some of the features that offer Spring Boot to customize a command line application, right? So here I have all the steps that we are going to cover in today's session. We're gonna create a Spring Boot application that will allow to search different customers applying different criteria. We will also have functionality to update a customer, and then we will also require authentication to perform these write operations, and also deleting a customer. Okay. So the first thing to notice to start developing a Spring Cell application is to import the dependencies in your POM. In this case, we're gonna need Spring Cell started. That provides all the infrastructure needed for developing CLI applications. And then we're also gonna have the starter web, because we're gonna use the REST client, the new REST client introduced in Spring 6.1 to communicate with the REST API. All right. So first, I'm going to show quickly that we have our customer REST service up and running, and we already have there some data with some customers in our database. Okay. And if we have a look at the expected data returned by the application, is a record that will be serialized as a JSON object, right? So that's basically what we are going to be consuming in this CLI application. Now, so that's our backend, basically, that we are going to communicate with. So it's going to be HTTP communication from our client, which is going to be a CLI application. So the first step to start is we need to register a command. And we can do that with annotations. All these Spring Cell provides a different set of annotations to define our commands and all the options, as well as different properties of those commands. So for example, the first thing we need to register a command is to create a class. And normally classes are grouped by functionality. So in this case, what I'm going to do is we're going to have a customer command class that is going to incorporate, is going to have all the commands needed to interact with the customer REST API, right? So what we need to do is use the add command annotation, and then optionally we can pass a group name so that all the commands in this class are grouped under this name. Okay. And then the command is just use a customer service, which is a service that, as I said, it uses the REST API, the REST client from Spring Web dependency to communicate with the backend, right? And is injected via constructor, as usual in Spring. So now we have our class, which is registered as a command class. And inside, we can add methods for each different command that we are going to declare. So in this case, I have here add command, another annotation, the same annotation, because it can be applied to types, to classes, as well as methods. And then I'm passing to different parameters, different arguments. The first one is the command name. So how are we going to invoke that command when the application is running? So in this case, the command is going to be find dash customer. And then a description that can be displayed when we are using a help command. And one of the things that comes with Spring Shell is that it incorporates built-in commands to facilitate the user experience. So we have a help command that I will show when the application is running in a few minutes. And when we type that help, we can see all the commands available in our application, and we can see this information. So we can see the description. That gives us more detailed information on that specific command. Okay. Now let's have a look at the method signature. So basically, when we are going to find a customer, we are going to pass an ID, right? The ID of the customer that we want to retrieve the information, right? And we use the apt option annotation, again, from Spring Shell project. And this marks the parameter as an option for the command that will be passed as an argument in the command line, right? When the user is typing. And again, we have different options, different parameters. For instance, I'm saying that this customer, the parameter for the command is required, so it must be informed. If it's not, an error will be displayed. And then we can also set a description, again, that will be useful information if the user requests more information in the help command. And the method body, very simple, it just delegates on the customer service to find the customer by ID. And one important thing is that the method signature, this returns a string, okay? And that's how it normally works with Spring Shell, because the data that we pass back to the command line is normally a string of information, right? That's why it has to be a string. You wouldn't normally pass back JSON or other format. The way of interacting with the command line is via input-output, is normally via a string. Then later on in this session, we'll see how we can display the information in different formats. So we'll have a look at displaying information in a table format. But for the time being, we'll just return our string representation of the customer, right? So that's it. Let's have a look now at the application code. Right. So here I have the same class that I saw earlier, the command, right? And the command customer service. Again, this service is just service layer, right? Annotated with the as service annotation from Sprints. Basically what it has is it has an API handler that is going to perform the operation on the communication with the backend, right? So if we go, for instance, to the method find customer, we'll see that it just uses the REST client with a get method, get HTTP call. We pass the URL, right, with the ID of the customer that we want to retrieve, the type of media that we are expecting. So we are expecting to interact with JSON data, the return data. Then we call retrieve, and we expect a body of the request, which is going to be of type customer response. Again, this is our record with the different information. And Spring Boot, because we're already using the Spring Web dependency, this will be automatically deserialized from JSON into a Java record object. Right? So let's see this in action. Again, we have the command there. Now I'm going to execute the application. Let me make this bigger. Yeah, as you can see, we have here the cell. And as I said, Spring Cell comes with built-in commands like help. And here I can see all the available commands. And here is the command that has been registered. Find customer by customer ID. So now I can just call it. And let's say I want to get candidate customer 3. As you can see, I get back the information, the different fields. So I have the ID, the status, the person info, etc. And that's it. That's as simple as registering a command in Spring Cell, right? Now we're gonna see a more advanced example where we are going to get a list of customers rather than a single customer. We're gonna fetch multiple customers. Okay. Yeah, another important thing that I mentioned is that normally when we run a Spring Boot application, we see the Spring banner and all the log. This is okay when we are developing our application and testing to find errors and to debug. However, when we are running this application in production, we don't want to display all that information because it's going to make the user experience lose its quality, right? So one of the things to do is to disable the login or send the login to a specific log file. So we can do that very simple, just setting up some properties in the application properties file, okay? And here are the properties, which are root. We are disabling the root and we are disabling the banner, right? We don't want any of that information to be displayed while the user is interacting with the application. All right. Yeah, we see the service layer. I'm gonna give a brief explanation of how it works, the service layer, just so that we have a better understanding of this application. So again, we have different properties to communicate to the REST API. Here we have the URL, right? The base URL of our backend, and then the username and password because it requires basic authentication. And that is also set up in the HTTP API handler. This is where we define our infrastructure to communicate, to make the HTTP calls. And as I said, it uses the REST client and it uses the base URL from the properties. And then it uses a default header because we need to pass the authentication header. Those are the properties from username and password. And finally, we have also defined a default status handler because we want to manage and handle any exceptions, any errors that are sent back from the backend. For instance, if the backend is down or if the request was sent with incorrect authentication details or any other HTTP error, then what we do is we can inspect directly the request and response object, and then we just extract the information and launch and throw a custom exception, a custom runtime exception with the status code and the error detail. Okay. So now let's go back to the second command. Again, the way to define our commands is the same. So here I have a second command. This time is going to be define customers, to find multiple customers. And we have two different parameters, okay, which are not required. So they can be passed or not, right? The customer status, which is just an enumeration with the different status of a possible customer. And then we also have the VIP, whether the customer is VIP or not, which is a Boolean, right? And again, the call is delegated to the customer services that will call the REST API endpoint to find multiple customers. So let's rerun our application and see if that works. Any questions so far? Anything that you want me to?
That seems good.
So now I'm going to run again the help command, and we'll see that we have a second command, find customers, right? And now we have two parameters, and the parameters are passed by Spring Cell in the order that they are defined in the method signature, right? If we do not specify anything else, right? So first one will be status and second one will be VIP. But we can also have what's called long names and short names. And these are identifiers for the parameters, right? And the way it's used is as you would find in any cell or any CLI in Linux or in PowerShell. You normally pass, if it's a long name, you have to pass a dash with the long name plus the parameter value. So that comes in pairs. The first one is the name of the parameter, and the second one is the value of the parameter. And we have also the option or sort names, in which case we can pass two dashes, and that represents a sort name. So that would be dash dash s and the status. For instance, let's suppose that I want to find all customers that are VIP. So I can say find customer dash dash v, which is the sort name for the second parameter, and I can say here true. Doing a single one, right? So for short names, it's a single dash, and for long names, it will be a double dash. So we can do also these two calls are exactly the same. And it returns a list of all customers, right? But as you can see, it doesn't look good. It's huge. It's a single line with all the customers. So we would be interested really in format this output, right? And for that, what we're going to do is use Spring, one of the Spring features that allow us to present the information in a more convenient format, all right? So Spring Cell provides a table class where we can create the representation of the data in a tubular way. So let's have a look at that now. Okay. So what I have here is an output formatter class where we have all the that is going to generate the tabular format, passing it a list of customers. So we're going to receive a list of customers that was retrieved from the call to the REST API endpoint, and then we are going to format that list of customers and present it in a more visual way. Okay. So let's have a look at how this works in Spring. Again, this is going to be a class that is going to take care of the formatting. We use it as a constructor injected in our command class, right? And this output formatted, basically, it has a method to convert to table. And as I said, it's going to receive a list of customers, and it's going to, again, return a string. But this time, the string is going to be a representation of a table. And for that, what we have is two different classes here. We have a class that is going to be representing the data, okay? And then we have another class that is going to be doing the formatting from the model, from the data, from the model. That's what in Spring Cell is called a table model, right? So the array table model is a class that represents a model for a table in an array structure, okay? And what we need to pass is basically an array object, and that creates the model object. What's going to be the array of objects? Well, it's going to be each row is going to be a customer. So what we have to do is convert the list into an array. And we also are going to add in the first position, right, as this list is being converted. And we're going to add a row, which is going to be the header. That's why we have ID, name, email, date of birth, IP, and status. All the different columns, basically. So each row represents a column, and each cell inside the row represents a value for that column, right? So let's see how to create a row. As you can see, the row is just gets a customer POJO or a customer DTO, and it basically returns a string array with all the different values. Very simple. And then this is going to be our table model. So that's going to be a bidimensional array in which each row of the array is going to represent a row of the table. So that's the model representing the data, and then we have the table builder. This is actually the class that is going to get the string representation of the table. And we have to pass in the model with all the information of the rows. We're also adding some styling. So what we want here is to apply border on the table. So that we display the table with a border. And then we just call the build and render, and then we can pass it the number of characters, the available length, right? And with that, we will have our data represented in a tabular format. So let's go back to our example, and now we're going to return a list of customers converted to a table. Yeah. The other thing that we need to do is we need to register this output formatter as a bin so that Spring is aware of its existence, right? That way, it can then this bin can be then injected into our customer command, right? That's basic Spring, right? How it works, the bin factory and dependency injection. So we are set to test our method and see if that works. So let's rerun the application. All right, again, we're going to find customers. Now I want to find the customers that are active, for example. So I can pass this one. And I can pass it the source name of the command, which is S. I think I can get it. And as you can see, we have here the tabular format with the border that we specified, right? The ID, the name, email, date of birth, right? So as you can see now, the representation of the data is much more pleasant, right? Any questions so far?
That sounds good. No questions so far.
Okay, then I'm going to move on to the next section, which is going to be exception handling. How can we manage exceptions in our application? Again, here Spring follows the same methodology as other Spring projects, and that's by you can set up your exception handling globally with exception handlers. So let's have a look. Let's have a look at that. So again, there are situations where we need to handle special cases or edge cases, and for that, we would need exception handling. For instance, what would happen if we try to find a customer that doesn't exist, right? So for instance, let's say here, customer we get an exception there, right? So as you can see, we get this exception, but we would like to display something with a better format, and also, if possible, with a more intuitive error message. Right? So here is where it comes the exception resolver, right? And we can set up an exception resolver in 2 steps. We can create a custom exception, right? And then define the resolver globally as a bean. And then Spring Cell will automatically auto-discover it once the application is run, and it will be applied to the application. So let's do that. Let's implement our command exception handler resolver. And then we can have methods there for different exceptions. We can have a common method for an exception and then check the exception type, right? Or we can have multiple methods for each exception type. That's, in this case, we're going to have a specific method where we're going to catch every single exception, and then depending on the exception type, we will manipulate we will enrich the data in a different way. So this is the same code that we saw in the article. We just implement our exception resolver, and we have to override the resolve method. Like, we get the exception. Any exception that is thrown is going to be handled by Spring, and is going to pass it on to our resolver. And here we have different types. If it's a client custom exception, this is an exception come from the REST API, like, for instance, this error where the customer was not found, right? Then we can have different type of exceptions, like resource access exception, in case our backend is down and we cannot connect to it. Conversion fail exception, again, if we have any errors when passing the parameters in the command line, if we are expecting an integer but we pass a string, then we will get an exception. For instance, we can do find customer, and I can type here something that cannot be parsed into an int, and exactly we're going to get that error. Yep. So that's the first step. That's done. We have our command resolver exception implemented, and then the second step is to register it. So I'm going to register it in my application configuration as a bean, similar to what we saw with the output formatted. We need to register this bean so that Spring can find it and instantiate it, and then it will be applied, right? Okay. So that's done. Let's check that the exception resolver is working as expected. Then I'm going to run the 2 last examples, trying to find a customer with passing an incorrect parameter, an invalid parameter. Yeah, and as you can see, it's changed, and now the error message is much cleaner, right? So that's the error message. Customer ID must be a custom positive integer. And the same, something similar happens if we invoke the method for a non-existing customer. Identity customer was not found, right? So that's how we can manage Spring exceptions, and then display the message in the specific format that we want. Another thing about the exception resolver is that you can pass what it returns is a command handling result. And this class, basically, it has two main members. You can have an exit code specifying whether the operation was successful or not. This is useful when you have a command line application that is non-interactive. In this case, we are having an interactive command application. So it is completely ignored by Spring Cell. But let's suppose that we have an application that is non-interactive, so it's going to run a process. Like, I don't know, we have to run an overnight batch process to insert many data, insert data, for instance, in a database. We could do this and we can put it into a shell script or batch script. And then when we invoke the command, we can check the error code, right? And if the error code is 0, normally it means that the operation was completed successfully. Otherwise, any other value, it means that there was some type of error. So that comes in handy when implementing non-interactive command lines applications. And then the second one is the message that will be the message displayed when the error is raised, as we can see in these two examples. Okay. So that's it for exception handling. Yeah, you can see these two errors. We've also seen formatting the output with the array table model, right, and the table builder. So now we're going to look at a few more features, a few more advanced features of Spring Cell. We're gonna implement two new commands for updating and deleting customers. But these operations, what we want is that they are going to require user providing admin privileges. So that means those commands will can only be invoked if we have login previously. That's the main point of command availability. That we, under certain conditions or circumstances, some commands need to have a previous action to be performed. For instance, if we have a command line application where we need to download an image, first we need to connect to the server from which we are going to download the image, and then we can download the image, right? In this case, it's going to be something similar. What we want is to have these write operations protected, and we are going to require a specific access. And so we will require authenticating the user, right? So let's go and implement these two new commands. We're going to have one more command to delete a customer and a second command to update a customer, okay? And again, it's going to interact with our backend service. So the command registration, again, I'm not going to give more detail because it's exactly the same steps that we have seen with the other two commands. So as you can see, we can have here a delete customer. And again, notice the nomenclature here, the way to use the command. This is what by default Spring Cell will use. It will take the camel case, the standard camel case notation from Java, and it will convert it in this other notation, right? This REPL notation, where each word is separated by a dash and all is in lower cases. And again, we're expecting a loan ID, and we're going to call to the customer service to delete the user and delete the customer. And again, the delete customer ID, what it does in the service layer is going to use the API handler with the HTTP delete method call, passing the ID, and that will delete the customer from the database. Right? Also here, basically. And the second one is the update customer. But the update customer is going to be a bit different because we are going to request user input. And why is that? Well, because we want to allow the user to modify each customer field, right? They will be able to modify the email address, they will be able to modify the name, and a few more fields. And to do that, we need to collect data. We have two options, right? One option would be to pass all the new fields when the command is invoked, right? So we will need pairs, right? So we will need first argument would be the ID, second argument would be the name, for example, and so on. But this could grow fast, right? This could grow large, and it wouldn't be, in terms of user experience, it wouldn't be very, it would be a bit annoying to have to pass in the command line all the fields. Instead, another option is to request each field at a time in the command, right? So the idea is that we want to update customer 5, for example. Our command we invoke by update customer 5. And if the customer is found, it exists, then we are going to prompt each field and asking for the user to type the new field information, right? So how can we do that? How can we request information from the command line? We can do that with what's called a line reader. And one important thing is that Spring Cell internally, it uses another library, another Java library called JLine. And it's actually JLine, the one that provides all that functionality to interact with the terminal and the console. Okay. So, then let's have a look at how to implement this new requirement in our application, that we need to get input from the user, right? We're gonna have a cell reader class that is going to actually have the methods to interact, to display the information and wait for the user input. So basically, this read line required, what it does is it receives a text that will be displayed on the command line, and then it waits for the user to enter with this read line method, right? And the read line method is comes from line reader, which, as I said, is a convenient class from JLine library to read information from the terminal. Okay. So exactly, we're going to loop through this until the user enters a value, right? If the user enters an empty value, clicking the enter key, then we're going to present the same information again until something is entered by the user, right? So that's why we check here if the value is entered, if the value coming from the value type by the user is empty, then we're going to get the terminal and write into the terminal this message and repeat the read line operation. Okay. And we have another convenient method here to read line from different options. So these are the list of options that we can pass. For instance, this could be for the user VIP, whether the user is VIP or not, or whether if we want to update the user status, we can just pass a list of strings with the valid options to be selected, right? Similar to the previous method, it's going to loop until, in this case, until one of the options is selected, is one of the values. One of the values entered by the user must match one of the possible options. right? So that is our cell reader. It's a utility class that will allow us to interact with the terminal, uh, reading information from the user. And then the other thing to do is, as usual, you need to declare the class as a bin so that it can be used in the rest of the application via normally constructor injection or setter injection, right? And we apply that to our customer command. So let's do those steps. So cell reader class, then with the line reader from JLine library, which, as I said, is what Spring Cell relies on internally when interacting with the console and the terminal. And then in our application configuration, the last part is to register the bin. So now we are ready to use this news class and start getting information from the command line. So here is the update customer command, and as usual, the first we're gonna receive the ID of the customer that we want to modify, the user wants to modify. That customer is going to be found, right? And then we're going to collect information from the user for different fields. For instance, name, email, date of birth, info, and VIP. And this delegates, of course, to our cell reader class that is going to read the line with the message that we are going to set, right? So this message will be prompted, and then we will wait for the user to type and enter the new name. And the same goes for the other fields. The only difference is that the VIP is a read line options, and we're going to pass two options, yes or no. So the user will have to select one of those options. Those are the only accepted answers that can be collected, right? And once done, we just update the customer with the information that we have retrieved, right? And if the operation was completed successfully, a message will be printed on the cell, right? So time to check if this works as expected. Going to enlarge this. Okay. Yeah, now we have 4 commands. I'm going to first find customer number 2. There we have the information. Now I want to update. Right, and here is the first prompt for the user. This is actually this line here. Now we are waiting for the user to type the new name, and it will be collected in our variable. And let's say John Smith. date of birth, and it's providing the current value, right, in between. This is the current value. Let's set a new value. Then customer VIP, and if I type something that is not yes or no, it will repeat the process. So let's say no. Right? Yeah. And everything went well. Customer 2 was updated successfully, and it returns the new value. Right? If we go and find the customer, we'll see that indeed it was the new information was persisted. So that is a way to collect information from the user. The Sprint Cell documentation also comes with some components, but there is still work in progress, and I tried to use those components, but they didn't work as per the documentation, or at least I was unable to make it work as it was shown in the documentation. So this relying on JLine and writing this class is an alternative solution. Okay, now we have our 4 commands ready. But what if we want to protect the user and delete operations because they are sensitive operations, they're writing operations on the database, and we don't want all users to be able to perform those operations. So we are going to secure those operations. And Spring Cell provides a feature called command availability, where you can specify rules for that command to be available or not. If the command is not available, it won't be able to be invoked, but it still can be viewed in the help. So that's the next step that we are going to look at. We're going to secure the update and delete operations, and it will require to have a login user, right? Yeah. So the idea is that whenever a user wants to update or delete a customer, it will have to be logged first. So it will require a login action before invoking those commands. So what we're going to do is we're going to, as this is a sample operation, a sample application, we're not going to have the user in the database. It could be done. What we're going to do is we're going to have the credentials stored in the application properties, and it will be just a single user for the whole application. But again, this could be easily implemented using the JDBC template or Spring API, other projects, and you can delegate the security to users in your database. We need one more dependency, Spring Security Crypto, because the password will be stored using the bcrypt algorithm. Okay, so we're going to generate a password with bcrypt, and that will be the password used in our application. We can see that in the application properties is where we are going to define those new values. So here we have the username, administrator1, and then we'll have a password encrypted with bcrypt. Okay. Yeah, see if I can remember the password. So this value is actually here. It's actually for the value for password 2. Right? And what we need is a login service. Again, the login service is a class that is going to read the username and password from the application properties using the add value annotation. This add value annotation allows to read properties from application properties, and we just pass the full property key, and it will retrieve the value from the key. And then we're gonna need a user that is going to be stored in the login service. That's going to be the log user, right? And as is usual in this type of operation, we're going to have a login method with username and password, and it just checks if the username and password match. That's here, right? Here we use the check password by crypt dependency, Spring crypto dependency, and we pass the password entered by the user and the encoded, the hashed password, right? If it matches, then we set the user so that the user is not null. Logout, it just sets the user to null, and we have a utility method to check if the user is logged in or not, basically a Boolean method. And now we're gonna have a different group of commands, which is going to be the login commands. These commands are going to be on a separate class because they are not related to the customer. If this application grows in the future, these login commands could be applied to another set of commands. Okay, so that is why they are in a different class. And the process is the same. With the add command, we pass the login service, and then we're gonna have two commands. One to log in, where again we pass the username and password, and the second one is going to be the password, right? And it's going to check if the credentials are correct, if the credential match with the user service, and then we're gonna have a logout method that it just removes the user from the login service. Once we have our class ready, we need to create availability beans that will be used, that will be applied into our commands. Okay, so how this works is, again, we need to declare a bean, which is going to be an availability bean, and it's going to contain the logic of whether it is available or not, which is going to be a predicate with a true that will return a Boolean. And then we need to apply this availability bean in our commands, in the commands that we want to, in this case, protect and secure, right? So here is the beans. So this is an availability provider, and we have one to check if the user is logged, and we ask the login service if the user is logged. Then we return an availability object with available. Otherwise, it is unavailable, right? And the same goes for user logout. It's going to check if the user is not logged in, and if it's not logged in, it's going to be available. Otherwise, it's going to mark it as unavailable. So this logic is going to be applied into the commands. And if the value returned by the predicate is true, right, is an availability command, if it's available, that command is ready to be invoked. Otherwise, it won't be, it will be disabled, right? Any questions so far here? Right. So now we just need to use the add command availability annotation and pass it the provider. So for instance, the login method, we want it to be available only if the user is logged out, right? Otherwise, it doesn't make sense to invoke login. And the opposite is for logout. It's only available if the user has not logged in yet, right? Has logged in, sorry. Otherwise, it doesn't make any sense to invoke the logout method. And now, in order to protect the update customer and delete customer, we pass the same command availability annotation and this provider. And again, this method will be available if the provider returns and availability available object, right? So let's do that in our project. And here we have our login commands. The availability beans are defined in the application configuration class. And now we need to apply these availability providers to the methods we want to secure. So let's go back to the customer commands, and here we're going to apply those availability commands. So these commands will only be enabled whenever this provider returns an availability provider with an availability class. If they return unavailable, they won't be enabled. So let's have that in practice. Okay. Let's invoke this help command. Yeah. And as you can see here, we have some things that have changed. We can see that these two commands are marked with an asterisk. That means they are not enabled. If I try to call them now, I'm gonna get an error, right? That is not currently available because you are not logged in, right? So I need to log in first. And for that, I'm going to invoke the login method. I'm going to pass the first parameter is going to be the username. And the second parameter, the password. If I enter a password that doesn't match, I'm going to get sorry. Username login incorrect. Now I am logged in, right? I introduced the username and password corrected. Now I am logged in, which means those commands are now unlocked, right? They were locked, unavailable, and they are now ready to be invoked. And as you can see, the login is not available because it doesn't make any sense to log in once the user is already authenticated. Okay. So let's call the delete method, delete customer. And customer 2 has been deleted successfully. So the user was able to invoke the method this time, right? If I try to find customer 2, it was not found. So that is availability. It's a really nice way to enable and disable commands, and it's useful when you need to have a set of required steps that need to be followed, and you can enable and disable them based on different criteria. There are a couple of more sections that I would like to cover before finishing the demonstration. One is about input validation. So Spring Cell is also integrated into the Jakarta Bean validation API. So that means that you can just import the dependency and you can use the annotations to validate input parameters. For example, in here, I have a constraint in the method find customer that if the range is out of these values, this message will be displayed. So I can and that's the message that we get, same as the message declared in the annotation. Okay. So we have all the power of Jakarta Bean validation integrated. We just need to put the dependency and start using the constraints, or even implement our custom constraints and apply them to the input parameters of the methods. Right? So that's input validation, very easy to apply in the project. And the last part I want to talk about is a bit about customization. Again, there is a wide range of customization options in Spring Cell. They are all available in the Spring documentation. I'm just going to focus in a couple of them. Okay, just a couple of small customization that so that you can see how it can be, how the CLI can be altered and manipulated. Right? The first one is going to be to modify the command not found message. So if I type here, I make an error, a typo, I'm invoking a that doesn't exist, and then we get this default message. Now this default message can be overridden and we can use our own custom message. To do that, we just need to implement a command not found message provider and declare it as a bean, right? With that, we can display a different message to the user. Right? And the second one is it is possible to change the prompt. By default, the prompt is cell, but this could be changed. And what we can do is we want to display a different prompt depending on whether the user is logging or not. If the user is not logging, then we just display the cell unknown. However, if the user is logging, we will display cell and the username so that the user is aware that he has authenticated and he has an authenticated session. Right? These beans can be registered in the application configuration. There is a second option, which is to implement your own provider class and mark the class as add configuration. The same goes for the command not found provider. It could be possible to create your own class and implement those interfaces and then override the methods. Sorry. But I think the bean option is cleaner and is not as verbose as the implementation. So now rerunning the application, we will see those changes in effect. Yeah, that's where we have cell unknown. So okay, now if I log in, the cell changed, right, from unknown to administrator. And if I call a command that doesn't exist, the new message will be displayed, right? So that's all for me. The other thing is that Spring Cell is also integrated into Spring Native. So this could be compiled into a native application. And then there is no need to distribute a jar file, right? So that's also something convenient. It won't require to have the Java runtime installed in the computer, just with a command, a native application, and it can be deployed and distributed, and you don't have to worry with licensing issues in case you're using a Java distribution that is requires licensing. You wouldn't want to distribute that. So in that case, it could be actually generated as a native application, right? Yeah, and that is all for me. You have any questions? Feel free to ask. Otherwise, we can just stop the session here.
Yes. No. Thank you so much for your presentation. Thank you so much for your demoing, and really was very good demo from your side. Thanks for your time.
Yeah, no, you're welcome. Hope you learned something new.
Yeah, of course.
Yeah, we can have cover more topics in future sessions. Yeah.
Yes, sure. So looking forward to see you in the future, hopefully.
Yeah.
Okay, thank you so much.
You're gonna come here.
Okay, I'm ending the stream now.
Okay.